All right, let's play with a really wild idea, a true cosmic what if. What would actually happen if our sun, that giant ball of fire that gives us light, heat, everything, just poofs, vanished? Not in a billion years, but right now. Gone.
But here's the absolute craziest part of this whole scenario. If the sun disappeared this very second, you wouldn't know. Nobody would. For a full 8 minutes, life would just carry on. You'd finish your coffee, send that email, completely oblivious. So what's with the delay? Well, this is our little window of blissful ignorance. For just a short while, we'd still be soaking up the last bits of light and feeling the gravitational pull of a star that, for all intents and purposes, isn't even there anymore. Let's really zero in on this number. 8 minutes. That's the travel time. It's how long it takes for light to cross the 93 million miles from the sun to get to us here on Earth. But, it's not just about the light. See, this is where it gets really cool. One of the big takeaways from Einstein is that nothing in the universe is instant. Gravity isn't some magical force that acts everywhere at once. Nope, it's a ripple in space-time, and that ripple travels. And guess what speed it travels at? Exactly the speed of light. So the news of the sun's disappearance, both the light going out and the gravity letting go, they travel together in the same cosmic package deal.
So that clock is ticking. The 8 minutes pass. And then it all happens at once. The first effects finally arrive. And they are, to put it mildly, dramatic.
And I mean instantly. This isn't a slow fade to black like a sunset. It's like someone flips a giant cosmic light switch. 1 second, you've got daylight. The next, you have the pure, inky black of deep space. The only light left would be from the distant stars and the other planets, which are still reflecting sunlight that hasn't, gotten the message yet. At that exact same moment, the leash snaps. The sun's gravity is gone, so there's nothing pulling us into that nice circular orbit anymore. Thanks to inertia, we keep moving at our blistering orbital speed, about 67,000 miles per hour, but now it's in a perfectly straight line. We're suddenly a rogue planet flung like a stone from a slingshot into the total darkness. So we're hurtling through space with no sun. The planet's main furnace has been turned off. Earth immediately starts bleeding its heat out into the void with absolutely nothing to replace it. A catastrophic planet-wide deep freeze kicks in right away. And this, right here, is the grim schedule of events. It's not one single disaster, it's a terrifying chain reaction. So let's just walk through this step by step. In just 7 days, the average temperature across the whole planet would hit -17 Celsius or 0 degrees Fahrenheit. The surfaces of the oceans, the lakes, everything would start to freeze solid, building up this icy crust that would just keep getting thicker. Fast forward 1 year, and wow, the situation is unbelievably bleak. The surface is now at -73 Celsius. That's -100 Fahrenheit. That is colder than any natural temperature ever recorded in Antarctica. The entire planet is essentially a giant wandering ice ball. And for life on the surface, the collapse is even faster. The second the lights go out, photosynthesis just stops. Plants are the foundation of pretty much every food chain, right? They start to die. Then the animals that eat plants starve. And then the animals that eat those animals starve. The whole surface ecosystem just completely unravels. And this might be the most bizarre part of the whole deep freeze. Over thousands of years, as the planet gets colder and colder, the very air we breathe will start to give up. The gases, nitrogen and oxygen, will cool down so much that they turn into liquid and then freeze solid. It would literally start snowing oxygen, covering the surface and leaving the planet in an almost perfect vacuum. Okay, so it's a frozen, airless rock flying through space. But could anything at all, survive this? You might be surprised, but the answer is, yeah, probably. But it would have to be running on a whole different energy source. The secret to survival is switching power sources. Before, almost all life was solar-powered. But after, any survivors would have to be powered by the Earth's own internal heat. Think about it. The deep oceans, insulated by miles of water and a thick new shell of ice, would actually stay liquid because of the heat coming from the planet's core. And this is where you'd find them, the last holdouts. Tiny microbes huddled around hydrothermal vents on the ocean floor, using chemicals from the Earth's interior for energy, a process called chemosynthesis. To these little guys, the sun's vanishing would be a total non-event. Their whole world is already dark in power from below. For them, nothing changes at all. Now, let's pull back. Let's zoom out from these tough little microbes on our frozen Earth and look at the bigger picture. Because remember, Earth wouldn't be the only one sent on this cold, lonely trip.
Jupiter, Saturn, Mars, every single planet, asteroid, and comet, they'd all get the news a little late depending on their distance, and then they'd have the exact same thing happen. The gravitational cord gets cut, and they too go flying off in a straight line, a silent exodus into the galaxy.
And that's the final, incredible result. The beautiful, orderly solar system we know would be completely taken apart. It would just become this expanding cloud of cold, dark worlds, each on its own solitary journey through the Milky Way, likely to never cross paths again. The anchor's gone. Everything just drifts away. So in the end, the sun disappearing isn't some big, flashy explosion. It's something much colder, much quieter, and in a way, much more final. It's a slow drift into a permanent frozen darkness, and it's a pretty stark reminder of just how much we depend on that bright, warm star in our corner of the universe.